Hello guys, greetings to every one of you and welcome to our special class today. We are going to be studying mathematics today, and the topic for our today's class is indices, surd and logarithm. So we're going to start by looking at indices. To begin with, I wonder if some of you know the difference between the two expressions I'm about to display to you right now, 4a and a to the power of 4. So many people have problems with such expressions. So we have reached a stage where we must know the difference between these two expressions. Now, I want you to know that in this expression, 4 here represents the coefficient of a. So this 4 here is the coefficient of a. But in this case, 4 here is the power of a, otherwise known as the exponent of a. So you start seeing the difference. You have started seeing where the difference is. So in one we have the power, in the other we have a coefficient. So now this is actually what we are going to be dealing with. Index is the power or the exponent of a number or of a variable. A variable is generally represented by an alphabetical letter, a letter of the alphabet. For example, in a to the power of 4, for a here, a is the variable, while 4 is the power. So it is important to know the difference that exists between such expressions. Also, among other things, we have 4a and a to the power 4. I want you to know that 4a simply means 4 times a. But I want you now to know that a to the power 4 means a multiplying itself 4 times. 1, 2, 3, 4. So you have a times a times a times a up to 4 times. That is what makes a to the power of 4. With our lessons, I am taking you from basic to complex. And I want you to know that you can write numbers as exponents of their simplest form. So that is the next thing we'll be doing after this small introduction to indices. We are going to be looking at how to write a number as an exponent of its simplest form. Writing a number as an exponent of its simplest form. We are going to start with a number like 16. If we take a number like 16, this 16 is 2 times 8, which is what? 2 times, this 8 is 2 times 4, which is 2 times 2 times, this 4 now is 2 times 2. So you notice that 16 is the same as 2 raised to the power of 1, 2, 3, 4. 2 raised to the power of 4. And this is your answer. We are going to do another one. We are going to do 100. 100 is equal to 2 times 50, which is the same as 2 times, now this 50 is the same as 2 times 25, which is the same as 2 times 2 times. Now this 25 is same as 5 times 5. So this is the same as 2 raised to the power of 2 times 5 raised to the power of 2, and that is your answer. Now this number is an index number. So when they want you to write a number in index form, this is what they want. You write the number like this. That number is in index form. While this number is in expanded form. This is in expanded form, while this answer is in index form. So sometimes you have a number to write in index form. You may also have a number to write in expanded form, and you should know exactly what to do. All right, ladies and gentlemen, I'll now proceed with the base of the base and the exponent. In that, I'm going to still take some examples how to identify the base and identify the exponent before we really start work, before we really start doing much work. I've spoken about this already. For instance, if you have a number like 5 to the power 8, 5 is what? 5 is the base. 8 is what? The power. Other people will call it the exponent. If you have a number like x raised to the power of m, x is the base, m is the power, or the exponent. I think you get a point. So now, without taking much time, if we have a number like 16 to the power of half, 16 is the base and half is the power. All numbers can be written in index form and also in the expanded form. We are going gradually, and now we must look at the rules of indices. I come again. Right now we are going to be looking at the rules of indices, wherein I'm going to give you 9 rules that you use to solve any problem relating to indices. Rule number 1, or law number 1, we call them rule of indices or laws of indices. Law number 1 is known as the multiplication law of indices, which states that a raised to the power of m times a raised to the power of n is equal to a raised to the power m plus n. So this is the multiplication law of indices, meaning that when the base is the same, you simply add or sum up the powers. That is multiplication law of indices. We're going to pick up an example from there. So what does it mean? It means if you have 2 to the power 3 times 2 to the power 4 times again 2 to the power 5 times 2 to the power, so your answer will simply be 2 to the power. You add up all the powers, 3 plus 4 plus 5, which will give you 2 raised to the power what? 12. Exactly. So that's just it. That's the multiplication law of indices. I will go straight to the point. We'll move on to the division law, which is law 2. So the second law of indices is the division law, which states clearly that a raised to the power m divided by a again raised to the power n is equal to a to the power m minus n. So in the case of division, you are subtracting the power. So if you have 3 raised to the power 5 divided by 3 raised to the power 2, your result will be that same 3. Then we subtract the power and we have 3 raised to the power 3. So that is work done. The third law of indices states that a raised to the power m and all that raised again to the power n is the same as a raised to the power m times n. What does it mean? Anytime you have a number, let's say 5 square, all this to the power 7, is the same as 5 to the power of 2 times 7. So the power now is 2 times 7, which is 5 to the power 14. And work is done. Law number 4. Indices. The fourth law of indices state that a over b, all these raised to a certain power, say m, is equal to a to the power of m divided by b to the power of m. So it means that how we can say it in ordinary English, we will say that the power of index of an index number is distributive over division. So the power is distributed over division. Same in the case of multiplication. So that is work done. We'll take, for example, let's say 3 over 4, all this raised to the power 4. This is the same as 3 to the power 4 over 4 to the power 4. You compute and you work on it. So that is work done. So it is the same with multiplication. So law 5 will now talk on the distributive law of multiplication. We will simply say that a times b, all that raised to the power m, is the same as a to the power m times b to the power m. Law 6 of indices will state clearly. Now, if you have, watch what I'm doing. If you have a to a certain power m divided by b to a certain power, that same m, all this to another power n, your result will be a to the power of mn divided by b to the power of mn. The next law of indices is the 0th power. Anything raised to the power of 0 is equal to 1, which means that 5 to the power 0 is 1, 5,000 to the power 0 is 1, 25,000 to the power 0 is 1. That is the 0th power. Now, the negative power states that a to the power of negative m is equal to, take note here, is equal to 1 over a to the power m. So the negative power takes a reciprocal. That is as simple as that. Also, it simply means that 1 over 2 is the same as 2 to the power minus 1. So that's the interpretation of that rule. Then the last rule of indices is the fractional power. When the power is a fraction. For example, you have a to the power 1 over a certain power n is equal to the n root of a. As simple as that. What does it mean? It means 3 or let me say 36 raised to the power of half is equal to what? The square root of 36, which is 6. It means 27 raised to the power 1/3 is what? The cube root of 27, which is the cube root of 27 is 3. Now, that same law, it means now that if we have 16 raised to the power 3 over 2, it means the square root of 16, then now raised to the power 3. Take note. And the square root of 16 is what? 4. 4 raised to the power 3 becomes your answer. So those are the laws of indices. Those are the laws of indices. I am going to give you an exercise, and I will warrant you to carry out the exercise completely. Then you will do it one after another, because I'm also going to be working with you. So I'm telling you what to do now. This is work to be done. When I'll display any question, I'll give you time to work. So you can go ahead, you pause the video and you solve it. Then you come back to the video now to check your answer and compare. So let's go. Question number 1. Question number 1. Simplify. Simplify. Simplify 8 to the power of 2x over 3. Simplify that. Go ahead, you pause the video, you walk, and then you come back for correction. Alright, so here we go. We have 8 to the power of 2x on 3. We have two different approaches that we can use. The first approach is this. You first of all know that this is a fractional power. So this simply means that we have the cube root of 8, then all this to the power of 2x. And what is the cube root? What is the cube root of 8? The cube root of 8 is 2. So I'm looking for a number that multiplies itself 3 times to give 8, which is 2. Then now to the power of 2x. But what is 2 to the power 2? 4. So you have 4 to the power x, which becomes your answer. So your answer is 4 to the power x. Second approach. You can also use this second approach by doing that 8 is first of all 2 to the power 3. Then all this to the power 2x over 3. So you see that this 3 will cancel this 3, and you're left with 2 to the power 2x, which is 4 to the power x. Work is done. Next question. Next question. Simplify. You are simplifying 0.0625. All this to the power of 1/4. 1 over 4 is the power. So simplify this. Go ahead and simplify. All right. So let's follow up now for correction. You are asked to simplify 0.062 to the power of 1 over 4. The first thing is 0.062 is the same as 625 is the same as 625 divided by 10,000. I hope you are fine. Why divided by 10,000? I hope you know how to change from a decimal to a fraction. It's not now that I'm supposed to teach you. However, to change from a decimal to a fraction, you count the number of decimal places. So if you count here, you have 1, 2, 3, 4. That's why you have 4 zeros here. So now, this is the same as this, or this to the power of 1 over 4. Very good. But so what does it mean? You are now looking for, according to the fractional power, you are looking for the fourth root of 625 divided by 10,000. Now, what is the fourth root of 625? You know that 5 times 5 times 5 times 5, 4 times is 625. So it means 5 to the power 4 is 5 to the power 4 is 625. Meaning what? Meaning that the fourth root of 625 is what? 5. And what is the fourth root of 10,000? 10. Now what is 5 over 10? 5 here 1. You do 5 here 1, 5 here 2. And this becomes your answer. It becomes your answer. And so work is done. Next question. Also simplify. After this, you take just one more question. 64 divided by 27, all this to the power of negative 2/3. So now, as simple as that, since the power is negative, what you will do to change the power to positive, now instead of putting negative 2/3, your power will become positive 2/3. But now what will happen is that you have to change the position of the numbers, meaning that 27 will come up and 64 will go down, since you have changed the sign of the power. So now what does it mean? Now you are having to find the cube root of 27 over 64, all raised to the power of 2. Very good. Now what is the cube root of 27? The cube root of 27 is 3. What's the cube root of 64? The cube root of 64 is 4. All this to the power of 2. So from there now, you have 3 raised to the power of 2 is 9, and 4 raised to the power of 2 is 16, and that becomes your answer. That is your answer. All right, last question, and we move on to the next lesson. So the next question is simplify. We have root y times cube root y divided by y cube. Good. So that is the question. We have to first of all start by, to simplify this, we are going to put it in linear form. Putting it in linear form, root y is y to the power half. That's the square root of y. Times the cube root of y is y to the power 1/3. Times, now this one is down, y to the power 3. So it becomes y to the power -3. So remember the multiplication law, which says that we have now to add the power. So our result is y to the power half plus 1/3 minus 3. So when you now do that, you're going to have that your answer is y raised to the power of negative 13/6. And that is your answer. Hello guys, so now we are going to look at how to solve indicial equation, meaning that we have to look at how to solve equations involving indices. So I'm going to be working a few of such questions with you as exercise or solved examples. So when I give any, you have to get to work and then you only come back to the video to get your correction. So let's start with question 1. Find the value of x in the equation 2x is equal to 16. So solve this equation. Now I want you to know that if 2x is equal to 16, you can make 16. You can write 16 as 2 raised to a certain power. Now you know that 16, all right, 16 is the same as 2 times 2. 2 times 2 is 4. 4 times 2 is 8, and 8 times 2 is 16. So it's 1, 2, 3, 4. So this is the same as 2 to the power x being equal to 2 to the power 4. And since the bases are equal, then the power must also be equal. That means x is simply equal to 4. You see how simple the equation is. Question 2. All right, question 2 reads: find the value of x. We have 25 to the power x minus 1 equal to 5 to the power x plus 2. So we have to find x. The first thing is express 25 as a base of 5 raised to a certain power. That means you know that 25 is 5 square. Then all this now times x minus 1, it being equal to 5 to the power x plus 2. We continue. This is the same as 5 raised to the power 2 times x is 2x, then minus 2 times 1 is 2, being equal to 5 raised to the power x plus 2. What does it mean? It means that 2x minus 2 is equal to x plus 2. That is the equation you are now solving. Now you have to bring this one to the other side of the equation. I hope you know this. When you do that, you have 2x minus x, meaning that x is equal to 2. You now bring this one to this other side. We call it bringing like terms together for those who don't know yet. So you have 2 plus 2 on this side, and x becomes 4. This is your answer. All right, so with that, work is done. Next question, we have if 5x plus 4 to the power of 3 equal 8, find x. So it is simple. Yeah, we have to put, we are first of all going to express 8 as exponents, as a base and exponent, trying to make sure that the exponents are the same. For example, you know that 8 is 2 to the power 3, and this also has power 3. So we are going to use that. We are actually going to express, this is 5x plus 4 to the power of 3 we'll express it as 2 to the power 3. Now that the powers are equal, the bases are also going to be equal. That means 5x plus 4 is equal to 2. So 5x is 2 minus 4. With this, we are saying that 5x is negative 2 and x is negative 2 over 5. And work is done. Next question. You have, if 5 to the power of x over 3 is equal to 0.04, find x. So now we have that 5 to the power x over 3 is equal to 0.04, which is 4 over what? There are 2 decimal places, so it's 4 over 100. So we are simply saying that 5 to the power x over 3 is equal to 1 over 25, because 4 here is 1, 4 here is 25. Alright, so what next? The next thing to be done is to express 1 over 25 as as 5 raised to the power something. So first of all, remember 1 over 25 must be 25 to the power negative 1. And 25 alone is 5 to the power 2. So this is 1 over 25 is 5 to the power negative 2. I hope you get. I hope you understand. I hope you understand what is done. Okay. All right. So we are saying that 5 raised to the power x over 3 is the same as 5 raised to the power of negative 2. What does it mean? X over 3 is equal to negative 2. Now we can cross multiply and we'll have that x is equal to negative 6. And work is done. Next question. Given that y is equal to 2x, so y is equal to 2x and 3 to the power x plus y is equal to 27. Find x. So now we are going to use substitution. We are going to use substitution to solve this problem. We are going to call this equation 1 and this equation 2. Now we are going to put equation 1 inside of equation 2. We call it substitution. Meaning that where we see y, in this y here, we are going to put the 2x. Now let's try that and see. We have 3 to the power x plus y. Remember, we are substituting. So y is now 2x will be equal to 27. So we continue the work. When we continue, you're going to see that we have 3 raised to the power of 3x is equal to 27. Now we're also going to express 27 as 3 raised to the power something. So you know that 3 times 3 is 9 and times 3 is 27. What does it mean? It means 27 is 3 raised to the power 3. So now we're going to put that here. Since we have 3 raised to the power 3x equal to 27, we are saying that 3 raised to the power 3x is equal to 3 raised to the power 3, because 27 is 3 raised to the power 3. So now since the bases are the same, the exponent or the power must also be the same, meaning that 3x is equal to 3. And if we divide both sides by 3, our x is equal to 1. And work is done. Next question. The next question reads: solve for x and y in the equation. So now when you look at this, you have a simultaneous equation to solve for x and y. So I'm going to give you these three. All right, we have 3 raised to the power x plus 1, x plus 1, yes, okay, equal to 27. That's the first equation. And the second equation is 4 raised to the power of y minus 2 equal to 16. So let's see what we can do. We have that 3 raised to the power of x plus 1 is equal to 27. So we can rewrite it as 3 raised to the power of x plus 1 equal to 3 raised to the power 3. Because 27 is 3 raised to the power 3. What does that mean? It means x plus 1 is equal to 3. I've explained that when the bases are the same, the power will be the same in such an equation. So what does it mean? X is equal to 3 minus 1, which is 2. Now let's continue with y. Given that 4 raised to the power y minus 2 is equal to 16, you know that 16 is y minus 2. So you know that 16 is 4 to the power 2. So what does it mean? It means y minus 2 equal to 2. Therefore, y is equal to 2 then plus 2, which is 4, and work is done. We have x as 2 and y as 4. Next question. Find the value of x and y. Given two equations, we have 2 raised to the power x minus y equal to 8. Then the next equation, we have 2 raised to the power 3x minus y equal to 128. So we have equation 1 and we have equation 2. So the first thing to be done, come to that equation 1 and we are going to replace 8 with 2 to the power 3. So we have 2 to the power x minus y equal to 2 to the power 3 equal to 2 to the power 3. So what does it mean? X minus y equal to 3. You can call that equation 1. All right. Then now the next equation that we had is 2 raised to the power 3x minus y equal to 128. So I want you to also know that 128 can be written as 2 raised to the power something. So which is 2 times 2 times 2, and 2 multiplies itself 7 times to give 128. So it's 2 to the power 7. So what does it mean? We can replace 128 with 2 to the power 7, and we are going to have that 2 to the power 3x minus y will be equal to 2 to the power 7, which means that 3x minus y will be equal to 7. We have it as equation 2. Now we can use the elimination method to solve these two equations simultaneously. So let's subtract. We have x minus 3x, which is negative 2x. We have negative y minus minus y, which is 0, will now be equal to, you now have 3 minus 7, which is minus 4. What does that mean? You now have that negative 2x equal to negative 4. If negative 2x equal to negative 4, you divide both sides by negative 2, and you have that x is equal to 2. But from equation 1, you have that x minus y is equal to 3. And from there, it means that y is equal to x minus 3. Y is 2 because x is 2. Then minus 3, which is negative 1. So we have that x is 2 and y is negative 1. And work is done. So guys, we have looked at many questions of this category, and I believe that no industrial equation is going to be more than you to solve. So I'm going to pause here. The next I'll give you now is assignment for you to do and submit for correction. So assignment: find assignment solve the equation for a and b. So equation 1, we have that 9 to the power 2a plus b is equal to 1 over 729. And equation 2, we have that 3 raised to the power a times 9 raised to the power b is equal to 27. You solve for find a and b. That's question 1 for the assignment. So again, for the assignment, question 2, after copying question 1, you have to take question 2. Question 2 reads, a bacteria culture doubles every hour. If there are initially 100 bacteria, how many bacteria will be present after 5 hours? That's the second question. Last question for the assignment. Suppose that a culture initially contains 1000 bacteria and that this number doubles each hour. Write a general formula for the number of bacteria n. For the number of bacteria n present after time t in hours. So that is it for your assignment. Thank you for taking the lesson, and keep on making progress towards your success until you find yourself passing your exams. God bless you.